Good afternoon, everybody, and thank you for joining this session. It's titled Accelerating Vulnerability Remediation with Automation. And what I'm going to cover is how we used Microsoft's Power Automate to bridge gaps found in technology API integrations. This was all in an effort to perform vulnerability scanning through remediation with some level of user acceptance testing, but no human interaction points in that process. A little bit about me. I've been at Optiv for 8 years, a little over 8 years. And for the last 3 years, I've been working in research and development, which I really enjoy. At 8 years, I have the least amount of tenure on my team. So I work with people who have been in security and been at this company for a very long time. Our team is responsible for identifying upcoming technology trends, and we get to prove out what's possible with the technology that we identify, and that's really cool. I enjoy the work that I get to do. I think it's cool. I'm constantly challenged, and I get to work with some really smart people. And with that, I'd like to thank my teammates, Rob, Woodrow, and John, for helping me on this project. They were a part of this project. They were extremely helpful, and I wanted to make sure they got credit where credit was due. Our agenda for the day, we're going to call out the main problem. I'm sure it's one we're all familiar with. We'll go into detail on our first attempt, the technologies used to try to solve this problem, the gaps that were identified when we tried to solve it with just using API integrations. We'll go into detail on how Optiv was able to bridge those gaps using Microsoft's Power Automate. Take a look at what our working remediation pipeline looked like. And keep in mind, this didn't involve any user testing at the time. So the last part we're going to cover is how we used robotic process automation to simulate user workflow testing to provide us that level of assurance. So we're confident that everything is working and we can push that patch or that security update to the greater business. And then we'll go into question and answer. This quote pretty much sums up the problem. There are just too many vulnerabilities, too many updates and patches necessary to test them all. We need some level of confidence to push out to make sure that we're not going to break a business process. We've used risk-based prioritization for a number of years, and we're going to patch maybe only criticals in a small amount of time. And then if they're medium or low severity, we're going to extend that time out. But what if we could actually automate the process, get that assurance, and reduce the mean time to remediate? Believe it or not, regarding workstations, and that's really what this talk is geared toward, Windows workstations, there are some organizations that we talk to that are performing basically blind patching, where if anything reaches or any vulnerability reaches a certain criticality level, they're going to deploy the patch regardless of any user testing and just kind of cross their fingers in hopes that that patch or that security update doesn't break a business process. It's not necessarily a bad idea. It's understandable why you would do that, but it's not always the best method. It's not the safest method. And you really want that level of assurance that when you push a patch or deploy a security update, you're not going to break a business application or a business process. Here's our first attempted lab design. Actually, truth be told, we tried this project about 3 years ago using a few different technology vendors, and we failed. But with the introduction of new technologies like Vulkan, Microsoft's Power Automate, we had the hypothesis that we would be able to fix the issues that we had last time and perform end-to-end vulnerability testing, vulnerability remediation, and user workflow testing without any human interaction. Also, keep in mind what we're talking about today is very focused on Windows workstations, Windows laptops, virtual machines. We're not talking about servers. Server patching is a whole different animal. The lab design here is not focused on Linux either. We had another lab design for Linux. Optiv was able to prove that we were able to perform end-to-end vulnerability scanning to remediation using Vulkan, Tenable, and Chef without any human interaction. That's in our white paper. I also want to caveat this lab design when it comes to the vendors chosen. Both vendors are very good partners with Optiv. It was my first introduction into Vulkan and how they helped solve the problem. And just because we use these and you might be using different technologies in your environment doesn't mean what you're using can't replace either of these technologies. On the right-hand side, we have the Optiv C Lab, which is physically located in St. Paul, Minnesota. In that lab, we have a bunch of virtual machines, Windows servers, SCCM was running, an Active Directory server, Windows 10 devices, as well as a Tenable scanner. That Tenable scanner would scan the environment for vulnerabilities on a time schedule. It would then feed that information to I/O, where it would be displayed back to the user and what systems were vulnerable, which criticality they were. That information was synced with Vulkan, also a SaaS-based solution. Given a particular vulnerability, that information could then be sent to SCCM to create a software update group as well as a device group to help us deploy our patches. Now that you have an understanding of the architecture, let's jump into some demo. What I'm showing here is this is an RDP session to a Windows 10 VM. It has an IP address of 172.16.20.201. I'm showing that there are some updates, but the update that we're looking for is not here yet. And you can see that the SCCM client is here. It's not waiting on any updates. And the last thing I want to show you is you can see Word 2013. So Office 2013 is installed. That's a vulnerable application that we will be updating for this demo. And I also wanted to show you that I have an RDP session to our SCCM server for our Source Zero demo. That's SZD1 is the host that I showed before that I was RDP'd into. So Source Zero Demo 1, and to prove that, I also want to show that the IP address is the same as the one that I logged into before. Moving over to deployment packages and software update groups, just showing here that both of them are empty for the purposes of this demo. Software groups is also empty, there it is. However, if we go to all software updates, you can see that we do have updates from Microsoft that are registered with this SCCM server. And lastly, I want to go to package updates. That is the location that we're going to be serving updates from. That's going to be our distribution point. Now I'm going to bring up Tenable. This is our IO instance. And what I want to do is I want to go to a previous scan. This scan was run against our vulnerable host, right there, our .201 host. It was run using an on-prem scanner. You can see that there are a lot of critical and high severity vulnerabilities, lots of mediums, even some low. I'm looking for a particular vulnerability or update that contains lots of vulnerabilities for Microsoft Office. We could see MS16099. If we go to the description, we can read a little more about the vulnerabilities that are covered in this update. We can see that there's code execution. So this is something that we would definitely want to patch. One last time, I'm going to go ahead again and look up the vulnerability. So you can see MS16099 or the security patch, and it is associated with the same host. This was found using a credential patch audit scan. So this is Vulkan. Vulkan is an amazing aggregator of host and vulnerability information of all kinds. In this demo, it's limited to Windows 10, but it's great for all operating systems, code projects, image scans. We have it integrated with Jira, Chef, Tenable, Sneak, and SCCM. We use this to prove out our pipeline for Linux as well as Windows servers. And this is vulnerabilities. I'm gonna go into assets though, and I wanna look for our host for the demo, SZD1. And let's click on it. And I'm going to do just a Control F to search for MS16099. You can see that it gets highlighted here. So Vulkan knows that this system is vulnerable to MS16099. We can see that they label it as critical. The source of this information is from Tenable. You can also search for specific vulnerabilities under the Vulnerabilities tab using their free text search it shows all assets affected by a specific vulnerability, the one that you search for. And as I click on it here, I can actually see that there are 4 assets um, that require this security update for Microsoft Office. And it shows fixes. Fixes will obviously vary by OS and architecture. So we can see that there are 16, or excuse me, 14 listed here for those 4 assets. It's good that we have the information, but now we actually need to do something with it. We need to take action on it. So Vulkan has automations. It's a lightweight automations that allows you to create playbooks. And I'm going to create one for this demo. I'm going to call it source 0. Let's call it demo 201. And I will type in the vulnerability information. And this applies to all vulnerabilities from Tenable that have fixes. That's my first condition. My second condition is going to be the name contains. And actually, just real quick, I'll show you some of the other available filters or conditions that are available to you. Affected vendors, CVEs, criticalities in there. So name contains, and then we're going to put in the name of that particular vulnerability that we're looking for. And on what assets are we going to look for? We could do asset name, IP, OS. It's a single IP for the demo, so we're going to put in 172.16.201. With the trigger action defined, now we have to perform a remediation action. I want to patch this system with SCCM, so I'm going to create a SCCM deployment action. In here, you can see that I'm going to create a device collection, and I'm going to name my device collection. We'll just do DC-SCDZ for device collection, source 0 demo. We can put in some description information. And then it's also going to create a software update group for us. So when this trigger runs, it's going to create a device collection for a particular device. And it's going to create a software update group. And that's going to be SUG for software update group dash SZD. And we'll put a description in here as well. I'm also going to create an email action. And this email action is going to have aggregated vulnerability data in it to a specific email address that I'm defining now. And are there any notes? And I'm going to add a specific note here, Remediation Pipeline RPA for robotic process automation. I'm going to go into detail on why we're doing this in a little bit. And I'm also going to run this on existing vulnerable instances, so ones that Vulkan already knows about. Now you can see that we have a new playbook and it is live. Just takes a minute or two, there it is, and we can see that a playbook action was just executed, our playbook action. But where that gets us to is here. It gets the scatter information going to Tenable, the Tenable information going to Vulkan, Vulkan creating a device group as well as a software update group. But it doesn't get SCCM to push the patches to our Windows 10 box. There were still 4 tasks that required human interaction in order to complete them. These were all done in SCCM, creating a deployment package, downloading the software for that deployment package, assigning a distribution point for that deployment package, as well as starting the deployment update. These were all things that we had to do manually that we still needed to automate. These were things that we dubbed the last mile because it was the last mile that we needed to figure out to complete, to automate, so there was no human interaction. These 4 tasks still do not include user acceptance testing. We still had to figure out how to use robotic process automation to perform that user acceptance testing and put that in the pipeline as well. So this is how far API integrations would take us. We still needed to introduce another form of technology to automate our last mile. We used Microsoft's automation technology to help us achieve our goal in finishing out our last mile. On the left, you're going to see that we use Power Automate. For those of you who are unfamiliar with Power Automate is a automation platform to really help. It's designed for power users. It uses logic apps under the hood. It has a concept of UI flows, which I believe has been rebranded now to desktop flows. And that is robotic process automation. They purchased a company called Softomotive about a year or two ago that does robotic process automation. Robotic process automation picks up the slack when there are no API integrations available. You can capture user inputs and user workflows and replicate them and perform the user tasks through a UI with robotic process automation. It's very cool technology. And on the right-hand side, we also used Azure automation. We used automation accounts, runbooks, and a lot of PowerShell to help us with our 4 tasks that we were unable to automate using API integrations. One additional concept that I want to cover, and this is a slide that I stole from Microsoft and tweaked a little bit, is the use of a hybrid worker. A hybrid worker for us was a Windows 10 VM that had a piece of software installed that allowed it to talk to Azure. What it really did was allow Azure to extend Playbook functionality from the cloud into our environment, our C Lab in St. Paul. And through that hybrid worker, we were able to query or perform tasks against local resources, which I think is really cool. So our hybrid worker is going to execute some PowerShell runbooks for us. And these PowerShell runbooks were defined under Azure automation accounts. I have a few. I have a remediation account is the one we're using here. And I'll close this out. And I'm going to go to the runbooks, and you're going to see several of them, and we're going to walk through each one. The first one we're going to talk about is the remediation runbook. And I'll just edit it so we can take a good look at it. Up top, we have the credential being used, the computer name that we're going to run against, as well as a very large script block, all of our commands. And we're basically going to load a PowerShell module. We're going to check a machine. We're going to check SCCM actually to see if there is a defined software update group. And if that software update group is 10 minutes, or if it's been updated in the last 10 minutes or not. If it hasn't, and it has a new deployment modification time, SCCM is going to be instructed to create a new deployment package named SZD. And that deployment package is going to be in that file structure that I showed earlier in package updates. Then it's going to create a software update group or apply that software deployment package to that software update group, I should say. The third step is going to be to give that deployment package a distribution point. So we can see SZD is the deployment package and our server that is defined as the distribution point. The final step in this script block is to start the deployment update. And that deployment update includes a software update group that was defined in Vulkan as well as the device collection name. And if this fails, we're just going to post that the deployment modification time is not new. But we still need to define how this runbook gets kicked off. How do we know to execute that runbook against the hosts on-prem? This is where Power Automate and Cloud Flows really helps. Here I am logged into Power Automate. I'm going to go to my Cloud Flows. You can see I have one named Remediation Pipeline. I'm going to open Remediation Pipeline. I'll go to edit it so you can see how it functions under the hood. And it only looks like we have 3 steps, but there's a lot more. So the first step is our trigger. When a new email arrives to a specific inbox in that to field from a specific email address, that includes attachments, it's going to trigger the playbook. It could be any importance, it doesn't matter. What we're going to end up looking for is a specific pattern in the body. That's the remediation pipeline RPA note that we put in the email that is sent from Vulkan to that same email address. So if that pattern matches, or the success criteria is equal to true, it's going to perform the next action, the next task. And that task in this flow is to log into Azure using an automation account that's already linked and run a playbook named Remediation under that automation account. That playbook is the same playbook that I just showed a few minutes ago with all the PowerShell that automates that last mile for us. And to show you what that looks like on the SCCM server side, I'm going to go to our software update groups. I'm going to show you that the SUG-SZD software update group has the packages downloaded and deployed. The number of collections that we're deploying to is just a single device collection in our case. And if you'll remember, that device collection was created by Vulkan, where it automatically put our demo host in that device collection. And if I go back to our software update library, we're going to see that I have a deployment package. So the deployment package is there. If I click on it, I'm going to see that I have the remediations or the updates listed. And to prove that they're sitting on this distribution point, I'm going to go to that package updates folder. And there should be a folder that says SZD. There it is. And if I click on that, I'm going to have the hashes of those updates, the hashes for those cab files. Moving back to the demo host, let's take a look at the SCCM client and see if there's a new update. Perfect. So this shows that our playbook executed successfully, and now the system has a new update waiting to be installed. Now our lab architecture looks something like this. Everything in blue has been added. The way that the flow would go is a time scan is executed on that on-prem Tenable scanner. The results are sent to Tenable IO. Vulkan syncs with Tenable at a certain time. And based upon the information, it kicks off that playbook, that lightweight automation for us. It performs two actions. It creates a software update group in SCCM. It also creates a device collection and adds that device to that device collection. At the same time, it kicks off an email. That email is the trigger for our second automation, which is in Power Automate, and it uses that hybrid worker to execute our PowerShell runbook, our automation runbook. And the outcome of all this was being able to perform vulnerability scanning to remediation based on risk with no human interaction. But this automated level of kind of quote unquote blind patching, it can be achieved by some tools already. And we were still missing that level of assurance that most organizations would want before deploying a patch or an update to a large user population. So this is where we introduce robotic process automation to the remediation pipeline. More than likely, it wasn't the intended use of the technology when it was developed, but I think it's a good application for RPA. And let me go into a little more detail on this. Once again, robotic process automation, or RPA, is the ability to perform tasks between applications where there are no API integrations. We can do this through a UI. And in Power Automate, under My Flows, under the My Flows tab, you have a section for desktop flows. So being able to perform a level of automation through a desktop user experience. It can be attended or unattended, meaning somebody does not need to be logged in unattended mode. In attended mode, a user would need to be logged in order for the automation to take place. I'm logged back into my Source Zero demo host. I have the on-premise data gateway installed, as well as Microsoft's Power Automate for desktop. I have two desktop flows. We're not concerned with the bottom one. This is another one here that I created for Source Zero. And I'm using this to simulate user workflow. This robotic process automation will be simulating how a user may test the functionality of an application. In this case, we're just going to test and see if the user, after the Microsoft Office update, is still able to send an email. Once it loads, we're going to see all the steps involved in this automation. These are all the actions that take place on the desktop. I'm going to show you how this works by just running this automation. And as soon as I hit play, I'm going to let go of the keyboard and mouse, and everything is going to be done automatically for me by desktop flows. And you can see now the state's in running mode. It automatically opens Outlook. It can take a little while for things to load, so if you've used robotic process automation before or any type of automation, you know that you have to put sleep timers in. So here it clicks on a new email, and it's going to populate the to field, the subject, as well as the body. So we can see I'm sending the email to myself. We have a subject, and we'll just type in source 0 demo, and it gets sent. That shows how robotic process automation can be used to simulate a user's workflow. And we're going to actually hold this open just for another minute to make sure that we get the response. And there's the response. So I sent it from my email to my email, so we know that the user, after the update, hopefully will be able to send and receive. That's the workflow that we're going to test. This user workflow, which we're again using as a simulation, so after Outlook updates or Office updates, can that user still perform the same functionality in Outlook? What will happen is this desktop flow will be added as a task in the Power Automate cloud flow, that longer flow. So we're going to put that in after an update is sent to the machine. Now there's a couple extra steps that we have to do. We have to force that machine to check in for an update. Then we have to wait for it to update. We have to ensure it got the update. And if it did get that update, then we're going to run the robotic process automation that simulated user workflow against an updated machine. So let me step back and show you how that looks. I'm going to go back to Power Automate. So let me bring up Power Automate here. And you can see I'm back in the Power Automate UI. I'm going to go to My Flows. I have Cloud Flows, which are shown here, as well as Desktop Flows. Under the Desktop Flows, you can see the same two that were on the local machine. So the Outlook Source 0 demo is the one that we're interested in. And now I'm going to go back to my remediation pipeline. I'm going to edit it because I think it's easier to see and understand when you go to edit it. And then after this is done, we'll walk through a completed flow. So it's the same trigger as before. When the email arrives, we're looking for regular expression match. If that condition is met and that match is made, we're going to do those 4 last mile steps. Now we want to actually force a particular machine to update. Again, using Azure Automation, we're able to force a machine to take an action and look for an update. I'm going to go back to my Azure Automation account. I'm going to go to Runbooks, and you're going to see that same name here, right? Remediation Force Client Update Check. In here, you're going to see that I have the credential. There's a credential in the credential store used. The computer name, that's our SCCM server. That's the one that I've been showing you SCCM from. And then our script block, which is the command block used for that we're going to execute. First thing we're going to do is import the PowerShell configuration manager commandlets if they're not already there. And then I want to invoke a CM client action. Microsoft shows us here that the CM client action sends a notification to a client to trigger an immediate client-side action. Our action is going to make the host, the SZD1 host, check for updates and see if there's any updates that need to be applied to the machine. So right there, we're defining the device name. We're going to invoke a command, the script block. We have our credential. The computer name is SCD1. And what that would look like if you're used to using SCCM, if we were to go to our SZD1 client, and if I go to Control Panel, then Configuration Manager, we can hit the Actions tab. And the Actions tab is going to show us the actions that the client can take. This is exactly what I'm showing through the PowerShell runbook in Azure Automation right here. So that forces the client to see if there's any updates and apply those updates. That's this step right here. Next, I have a wait 2 hours. And for the purposes of demo, I'll actually open it up and show you. I compressed this timeline to 30 seconds, so I didn't have to pause the video and make everybody wait for 2 hours. What this does is it gives the system time to perform that update. If there are multiple updates, it can take time. And now I need to check to see if that update was successful. There's a few different ways to do this. The way that I decided to do it was actually to check if the deployment itself was successful. I created another PowerShell runbook in Azure Automation. We'll edit it here, and then you can see what it looks like. The top part's the same, right? We're going to get the cred. We're going to launch this against the SCCM machine. Script block. Again, this was just for testing. I imported the module every time. And now I want to get the deployment. The collection name is DCSZD, and I want to see if any of those deployments have been successful. So if the deployment object contains 1, that means it's successful. So the host is up to date. Otherwise, the host has not been updated. So that deployment didn't take place. I can trust this because I only have one host in this device group. And then again, we're going to invoke the command that script block everything above using the credential against the SCCM server. That's how we check to see if the system has been updated. If it hasn't been updated, the job will fail. So I actually have a step in here to check the output of the previous Azure automation job. And it's put into a condition, right? If that condition where the host is up to date or the output says host is up to date, then we're going to continue in the yes column. If it's not up to date, we're going to send an email and we're going to tell me, because I'm the user, that the remediation pipeline failed and I have to go figure out what the errors are. This is just a very basic email saying that the pipeline failed. There are other things that can be added, and this is an example of a failed pipeline run and me receiving that email from Power Automate. If it doesn't fail, it continues on to the next step. That next step is to run that desktop flow. You can see I'm going to run that Outlook Source Zero demo desktop flow. The run mode is unattended, so no user has to be signed into the machine, and it can still take place. And if that finishes successfully, I know that I'm okay to update a larger device group. If everything finishes and it finishes successfully, it's updated. Now I have my assurance that I can push to a larger group because I know that the user workflow test against the updated system has taken place successfully. Using another automation runbook, we're going to tell SCCM to apply a software update to a different device group. Very similar to the ones ran before, except the script block toward the bottom is a little bit different. And this is the deployment update that we would like to start. There's our software update group name. And now the collection name, the device collection name is different. So it's going to be Windows Workstation Win10. And on the SCCM server, I can check and see which assets are in that group. So I will double click on it. And opening it up, I can see that I have 3 devices. One of them is actually our demo device because it's a member of this group as well. Now let's hop back over to our Power Automate flow. Let's close that. We're going to get the job output from the step above. The very last thing that we're going to do is we're going to send an email to the requester, in this case it was me, that the vulnerabilities had been detected and received from Vulkan for the demo workstation. We'll add those to from the body of the email to this email. SCCM has created a software deployment package for the host. It shows us the status details, and then it's going to just give us a little more information. Again, the text here can be anything. And also keep in mind during this flow, there are other conditions that can be put in place to map better to what you want to do. In order to get our remediation orchestration automation pipeline to run correctly on this demo host, I have to revert changes that were already made. So what that means is I need to go in and uninstall the update. So that way the next time Tenable runs, it sees that this host is still vulnerable. So let me uninstall this. And when Tenable syncs with Vulkan, or Vulkan makes that API request to Tenable, it's going to see that once again this host is vulnerable and it's going to trigger that playbook. So I have no pending updates. The other thing I'm going to need to do, and I've already done this, but I wanted to show you, is I've deleted the software update group. So that's no longer there. Actually, I don't have any on this SCCM server. There's no deployment packages. I'm also going to have to go to our package updates folder and delete that SZD folder that contained our cab files for our updates for those hosts. And as you can see, there's none there either. The last thing I have to do is verify that I don't have a device collection there, that DC-SZD device collection. So that's perfect. Now I had to pause the recording, but what you're going to end up seeing is a scan that executed. We're going to see the host that was updated. We're going to walk through the entire flow. So here, Tenable had a scan that was executed against this host. We're looking for our specific vulnerability to ensure that the scan picked it up this time. So the host is still vulnerable. We can see that, and we can see our host. The next thing we needed to do is sync with Vulkan. So I'm going to go back to Vulkan, and we can see that there are two actions taken. These actions were an email action as well as a SCCM action. Those actions were the ones that I've shown before. That's good. Our playbook executed. And if I go to my playbook, I'm going to see that the email matched the condition. All of the subtasks were executed correctly. I had to actually tweak the time to 10 minutes instead of 2 minute or 2 hours, and then I switched it back for the other demonstration. So that was a note for me here that it was switched. And you can also see that the host has been updated. So it executed the RPA task, that user workflow testing. So we emulated our user workflow test. And then we also pushed the patch to a different device group, as well as sent an email to the user. Let's go back now on our SCCM host and take a look. There's our software update group. Our software update group exists. Under deployment packages, we have our SCD deployment package. In terms of device groups, we have our DC SZD device group added back. You can also see under the deployments for this device group, we have our deployment task. Under the Windows workstations device group, we also have that same update task. So it's been tested and it's been pushed to that secondary group. I'm also going to go back now to our demo host and go under updates, and we can see that the update was once again installed on this particular endpoint. That's perfect. The last thing that I'm going to do is go to my email and show you an example email of what the user receives after everything is tested correctly. We have an email sent. It has the device plugin, it has the host information, it has all the remediation information listed out in detail from Vulkan. And if I go to the bottom, I'm also going to see that we have our note in there that triggered the playbook. And toward the bottom, we have the text that was executed, or the text that was inserted into the outgoing email as the last step of our Power Automate flow. So this is perfect. So our entire end-to-end vulnerability scanning, update, as well as user acceptance testing using RPA has executed successfully. Let's look at our finished lab diagram. This is a very busy slide, but I'm going to walk through it. If there are questions afterwards, please don't hesitate to ask. You'll see in green the addition of a Windows 10 RPA host. That Windows 10 RPA host is actually our Source Zero demo host with the RPA Power Automate for desktop component installed. To kick it off again, our timed Tenable scan scans the environment. It reports the results to Tenable IO. Tenable IO and Vulkan sync. After Vulkan has the information from Tenable, it checks to see if any of the data will trigger a playbook. We know that it does. It performs several actions. It performs two actions. The first action being to SCCM. That remediation action is to create a software update group as well as a device collection. At the same time, an email is sent to a predefined email address, which kicks off our Power Automate flow. The information in that email will run through all of our runbooks. Eventually, it gets to the point after the host has been updated that it will execute a robotic process automation or desktop flow against the endpoint. That endpoint, again, is our Source Zero demo that was updated. It had a Microsoft Office update. The workflow that RPA is simulating on the user's behalf is that of being able to send an email. Also, we could see if we could receive that email. If that functionality is there still, no process is broken, what will happen is another Azure Automation Runbook will apply the software update group to a secondary or larger device collection. And depending on the schedule for that device collection and those hosts, depends on when those hosts get updated. For the purposes of the Source Zero demo, I thought it was also easy to pick a single vulnerability, a single application that was at risk. But what we've tested is actually changing the Source Zero playbook in Vulkan to critical. So all vulnerabilities from Tenable that match a severity of critical from Vulkan will kick off our playbook, our Power Automate flow, and run through all of these steps every single night that it meets that criteria, which I think is very cool. One of the things that's not added to this pipeline, and in hindsight, we should have probably done it, is to add a remediation scan from Tenable to the host to also ensure that the host has been patched. That would be another way to prove that the host had the update. You would no longer see that vulnerability in Tenable. And it would have made sense to put that in as part of this project. Again, hindsight is 2020. That remediation scan would provide us an extra level of assurance that that system was no longer vulnerable. Another thing that I wanted to add to this pipeline, which I'm going to do so, and there will be an article listed on Optiv's Source Zero site soon, is adding mandiant security validation, used to be known as Veridin, which is a tool that performs efficacy testing at a network and endpoint level. I was going to put a efficacy test as part of the pipeline after the system has been patched to, again, ensure that it's no longer vulnerable and can't be attacked in the same way. For those of you who may be new to Optiv, Optiv has a section of their website dedicated to technical content. That's where you could find a lot of information from the speakers who are talking at Source Zero Con. My article is listed here. It's basically a step-by-step of how I was able to accomplish what we went over today. It also has the PowerShell runbooks that I used in the Azure automation portion of the flow. So if you're interested in those, they're listed here. There's some great content on here written by some very smart people, so I would encourage you to go and check it out. Other areas of reference for this project, if you search Accelerating Vulnerability Remediation on Optiv's website, you can find a download link to our white paper when it goes into great detail on more than things that we discussed here today. It includes remediation, orchestration, automation pipelines for Windows servers, Linux servers. The other thing that you can search for is best practices for automated vulnerability remediation. This is a field guide that we also published based upon the content that came out of this project. The purposes of our project was to prove what's possible. There might be many ways to improve on what I showed you here today. There might be other technologies that can also be used and achieve the same goals. It's just really cool to see that technology has come far enough that we can do end-to-end vulnerability discovery to device remediation with a level of user acceptance testing where there's no human interaction. And I think that's pretty amazing. I just wanted to say thank you again for attending this session. Please attend the other sessions. There's some really great content. Just a reminder, if you have any questions, please submit them through the question box and I will try to answer them for you. Thank you.